This is a summary of the pilot product in progress made in the Grow Main Street application in the Maven platform. This is Molly.
We've been working on how to make an IoT device and learning what it does. So, IoT stands for Internet of Things, and this device measures temperature and humidity. I think that a way we could use this device was we have a pet, and our pet's cage needs to stay at a certain temperature, and we need to know what temperature it is at all times. So, like if it gets too cold, we'll know. If it gets too hot, we'll know. So we could leave this in there. It would send an alert to my device. In this case, it'd be my phone. And then I could go in there and fix the problem. I think that for this project, you definitely need to have attention to detail and you need to be a hard worker. I enjoyed this project, and I think it was a lot of fun.
What did Molly build? Molly built an IoT device, as seen on the left, which is a sensor that measures temperature and humidity remotely, transfers it to the Google Cloud, and reports the temperature and humidity to any internet-enabled device, like a phone, as Molly described. How did Molly build this device? By logging into the Maven platform and accessing the Grow Main Street application, Molly was able to access content that's been pre-developed to help guide her through building an Internet of Things device. In this case, a temperature and humidity sensor for the Precision Agriculture Technology project. Through pre-developed content and videos that introduce concepts about what Internet of Things are, and through step-by-step standard operating procedures, which walk a student through the entire build of the kit, Molly was able to successfully build the kit, test the kit, and report data to the cloud. As an example, video content outlines how to unbox the kit and identify the parts. Step 2 is then learning how to power the device and get it connected to the cloud. And as you can see by the sequential step, things like assembling the kit and uploading deliverables, Molly was eventually able to reproduce this deliverable and ultimately package her device and measure temperature and humidity remotely. Once Molly finished her IoT kit build and prepared the video summary of her learning, Molly then engaged in career exploration. In this case, it was for John Deere and Company, and she explored what it means to be an electrical engineer and how electrical engineers at John Deere use IoT in today's modern agricultural applications. Molly was also asked to make a logical connection between what she did in building her IoT device and how this applies to the job she explored with John Deere. Additionally, Molly was able to learn about educational programs available to her that are aligned to Internet of Things. She was able to add those to her career goals for future academic and educational planning. She was also able to make logical connections between the educational program and the activity she completed. Finally, Molly was able to reflect on her learning and associate her feeling. As Molly is navigating through the Grow Main Street application, along with other applications delivered through Maven, Molly's building an academic record that reflects her profile, her career goals through career exploration, learning goals, educational background, past work experiences, groups that she's affiliated with, certificates that she may have earned, demonstrations of employability skills, soft skills, and different job functions that she's mastered. Throughout the project, Molly is building an academic record of competencies called job functions that can show her, her teacher, or a future employer what she's able to do. When Molly selects this part of her academic record, Molly recognizes that she's been awarded a seal of proficiency by her teacher. Molly's video reflection is included, time engaged in the activity, as well as each step-by-step artifact of evidence demonstrating that Molly did the work. Additionally, in Molly's record, each competency that Molly has demonstrated is also associated with specific tools and technologies. In this case, the particle argon IoT device. And finally, the associated standards. By clicking on an tag, Molly can see what standard she's demonstrated, and more importantly, evidence of her demonstration of that standard and her teacher's verification. As Molly progressed step by step through each part of the IoT kit build, she was uploading artifacts of her work. In the near future within the Maven project, as Molly uploads her artifacts of evidence, responsible AI will give her feedback if her artifact is meeting standard. And if it's not, corrective action that she can take. These are just examples of what that feedback could look like. This is intended to help Molly in successfully progressing and allow the teacher to work with individual students who may need even more support in implementing the feedback. As a part of the responsible artificial intelligence incorporated into the Maven platform, not only will her uploads of evidence of her work be evaluated for accuracy, but Molly's presentation and reflection on learning can also receive feedback. In Molly's initial video, she hit the mark in many ways, but there were a few things that she could have done to improve that video. Molly was provided with this feedback as prepared by her teacher currently. She took the feedback and incorporated that into her final video. The ability for the teacher to provide this detailed feedback in real time for each and every student can only happen with the incorporation of responsible AI. And that is our goal in this project, is to help students and teachers have the very best learning experience.